All right, let's peel back the screen on your phone or your laptop for a second. Today, we're going to decode the fundamental language that makes everything you do possible. We're diving deep into the world of binary and hex, those hidden codes that let us and our computers talk to each other. So let's just jump right in. At its very core, every single thing your computer does is actually based on a surprisingly simple idea. It might seem impossibly complex on the surface, but really, it all boils down to a secret language. I mean, just think about what you do every day. Every photo, every message, every video. It all feels so rich and complicated, right? But underneath all of that, there's this constant invisible conversation happening inside your machine. And that brings us to the big question for this whole explainer. How on earth can we build our entire digital universe from just two little digits? Well, the answer is literally the foundation of all modern computing. The answer is binary. It's a language of just off or on, represented by 0 and 1. Now, this isn't just some abstract idea. Inside your computer, there are billions of microscopic switches called transistors. Each one can only be in one of two states. Off, that's a 0, or on, that's a 1. Every single thing your computer does is built on that simple physical pattern. So, computers absolutely love binary. They thrive on it. But for us humans, it's a total nightmare to read. So how do we bridge that gap? Well, programmers and designers have this really elegant shortcut, one that you've probably seen a million times without even realizing it. And here's the problem in a nutshell. While those long strings of ones and zeros are perfect for a computer's logic, they're incredibly difficult for our brains to process. It's just a wall of numbers. It's so easy to make a mistake, and almost impossible to spot one. We needed a better way. And that better way is hexadecimal, or just hex for short. It's a base 16 system. So what does that mean? It means it uses 16 symbols, our usual numbers 0 through 9, and then it just borrows the letters A through F to stand for the values 10 through 15. Its entire purpose is to make binary easier for people like you and me to work with. Okay, so check out this table. This is where you can really see the magic behind the shortcut. Notice how each single hex digit on the right corresponds perfectly to a unique group of 4 binary digits. For example, the number 9 is 1001 in binary. The moment you go one step higher to 10, hex just uses the letter A, simple. And all the way at the bottom, the letter F always represents 1111 in binary. It's this perfect 1 to 4 mapping that makes hex so efficient for us. Let's see it in action. Take a look at this binary number. It's pretty intimidating, right? This string of 24 digits actually represents a very specific shade of orange. Now, just imagine trying to type that out without making a single mistake. Yikes. And here's the solution. This is the exact same value, but written in hex. Instead of 24 digits, we have just 6. It's so much cleaner, way easier to read, and you're far less likely to mess it up. Now, it's important to remember, the computer doesn't actually use hex. This is just a shorthand for us humans. The machine will always translate this back into that big, long string of binary. So let's see this system in action in one of the most common places you encounter it every single day: color. Yep, this simple code is what gives our entire digital world its vibrant palette. This is the hex color code model. It's a 6-digit code where the first 2 digits control the amount of red, the next 2 control the green, and the final 2 control the blue. And that little hashtag in front, that's just a signal telling the computer, hey, what comes next is a hex number. So, since each of the 3 primary colors gets 2 hex digits, that allows for 256 different levels of intensity for each one. You can go from 00, which means none of that color at all the way up to FF for the maximum possible amount. And here's where it gets really wild. When you multiply those 256 possibilities for red by 256 for green and 256 for blue, you get this, over 16.7 million distinct colors. That's the entire palette of your screen, all described by that simple 6-digit hex code. So let's look at how this works in practice. A code like hashtag FF0000 means maximum red, but 0 green and blue, giving you pure bright red. On the other hand, hashtag 0000 means no light at all, which is black. And if you turn all the colors up to their maximum value, hashtag FFFFFF, you get pure white. It's a beautifully logical system. Okay, so we've covered numbers and colors. But what about text? How does your computer know the difference between the number 65 and the letter A? Or how does it understand emojis and all the different languages in the world? This is where character sets come in. You can think of a character set as basically a giant dictionary that a computer uses. It's a standard list that assigns a specific number code to every single letter, symbol, and punctuation mark you can type. When you press a key, the computer just sees the number. For decades, the main standard was something called ASCII, but as a 7-bit system, it only had room for 128 characters, which was fine for English, but totally inadequate for a global internet. That's why the world shifted over to Unicode. By using more bits, anywhere from 8 up to 32, it created a massive space for characters. The result? We're talking over 130,000 symbols, representing virtually every language on Earth. Plus, of course, all the emojis we use every day. You know, this shift to Unicode was one of the most important, yet invisible, upgrades in digital history. So let's just touch on why this universal standard is so absolutely vital for the internet we all use today. It's thanks to Unicode that your name can appear correctly in an app no matter what language you speak. It's the reason we can have a single internet where someone in Japan can communicate seamlessly with someone in Brazil. It ensures that text, and even emojis, have a consistent meaning absolutely everywhere. And so, we've kind of come full circle, from the millions of on-off switches inside your phone, to the colors on the screen, to the very words in this explainer. It all traces back to those simple patterns of zeros and ones, organized and interpreted through these really clever systems like Hex and Unicode. Which leaves us with a final thought. Now they've had a little peek into this hidden language, how might understanding the fundamental building blocks of technology change how you see the digital world? Something to think about. Thanks for watching.